Good morning. All right, midterm 2 is done and dealt with. I think this is, we've got 3 more weeks, 4 more weeks, 3 more? 2? Well, this one and then 2 more, right? Yeah, so 3. That's good. 6 lectures. That's a good amount of time. We've still got a bunch of stuff to do, but we're actually doing surprisingly well in terms of progress about the things I wanted to talk about. So you'll get the midterm back on Thursday. Is that a fair forecast? All right, so you'll get it back on Thursday. So the only reason you attended today is to figure out what your midterm grade was. Go hang out in the sun. That's a suboptimal decision. You should be hanging out here and absorbing economics because that'll be on the final. Any questions about anything? Economics. All right, let's go. What we did last time, we started talking about this general equilibrium stuff for a little bit, which was more like a warning than a real treatment of general equilibrium, because you can take a whole class on general equilibrium if you want to. That's painful. But the basic notion about general equilibrium was here, when you look at markets in isolation, and you shock markets, which is econ speak for you change things that affect the outcome in a market, right? So you put a significant tax on one of the goods, or a subsidy, or a price ceiling, or a price floor, assuming that there are no spillovers into other markets, might be a reasonable assumption in some settings, but for most major policy interventions, there will be some sort of consequence for other markets, where people will leave one market, move into another, and then might spill back over into the market you're looking at. So thinking about the world as a set of interconnected markets is a much more reasonable way to think about it than just thinking of it as a bunch of markets that aren't connected to each other. So how policies and changes in information or other things like that actually affect one market could have major ramifications for other markets, which might spill back over into the market you're looking at. So just keep that in mind. Then we started talking about my favorite topic in all of economics, which is market failures, right? Market failures, if you look at your book, market failures take up about half of a good economics textbook. And the first one we looked at, and we're going to continue looking at today, is that of Monopoly, all right? Monopoly is also the greatest board game ever, but that's not what we're talking about here. Actually, Monopoly itself, I guess if you win, you end up with a monopoly. I guess that does make sense. But in general, it's not a game of how a monopolist operates. So what we're going to do here is we're going to try and figure out what a monopolist does, right? How does a monopolist determine what quantity to produce and what price to charge, and whether that's actually different from the welfare maximizing price equals marginal cost type setting, and what the consequences are for that. So what we're going to see is that consumers get screwed, and the monopolist does pretty well, all right? Not that surprising. But there'll be some really nice intuitive findings here, and we'll play with the monopolist a little bit about how can we potentially fix this monopoly problem, and that'll be a really depressing part of the lecture. But the big insight, and that was kind of boring last time, is if you think about the perfectly competitive firm, average revenue, the number of dollars you take in per unit sold, is exactly equal to marginal revenue over all of consumption, because it's always price, right? Each additional unit you sell, you get price dollars for. That means on average, the average number of dollars you get per unit sold is price. So average revenue and marginal revenue are the same thing. Then I drew this totally confusing graph, which I actually don't think is all that confusing, which showed that for the monopolist, since he or she is the only, so I'm going to make the monopolist he, okay? It's not gender specific, but I'm just going to stick with he for now. So I'm going to stick with the monopolist who faces this whole demand curve now, right? Not this horizontal residual demand curve where, however much a farmer in a perfectly competitive market sells doesn't affect market price. The monopolist faces the entire market demand curve. That means if he sells more, price goes down for all units he sells. If he sells less, price goes up for all units he sells, right? The monopolist still only charges one price for all units, right? This is different from something we're going to talk about called price discrimination, where a seller can charge different prices for different units sold. That'll be exciting. But that's not what I'm talking about here. Here's one seller in the market that sells each unit at the same price, but faces the entire demand curve. So I drew this picture by hand last time here, and just to remind ourselves a little bit what this is, if I'm a monopolist and I go from producing 2 units here to producing 3 units, right? At 2 units, I got the higher price up here. So if we put some dots on here, right? So at 2 units, you get this price right here. So total revenue was the box that has the red dots as its corner. So it's price times quantity. So that's one rectangle. If I increase output to 3 units, then price drops for all units sold, right? At 3 units, now I get this many dollars for it. So total revenue is now the rectangle with the blue dots at its corner. Right? So how does total revenue change? Well, we go from the red rectangle to the blue rectangle. So what you do is you lose that little area A, and you gain this big area B right here. So before, what happened is you sold 2 units that you sold at the higher price. Now, you're selling those same 2 units for a lower price, right? Because now you're selling 3 units and price drops. So for the 2 units you previously sold at the high price, now you lose area A, which is 2 times the change in price. Quantity times change in price. But you're selling 1 more unit at the new price. So 2 to 3, the width of this rectangle here is exactly 1 unit. Its height is exactly the new price. So you gain P dollars in new revenue, right? So there's this trade-off. You sell 1 more unit at P dollars, but the price you get, the number of dollars you get per unit for the units you sold previously goes down by whatever the change in price is. So marginal revenue is going to be B, that's what you gain, minus A, right? So not quite get that. That's marginal revenue. But why does it change? Well, if we move further out here, let's say you're selling 20 units, then that red box right here is going to be this box right here. Right, that's total revenue at 20 units. So figure out what price is at 20 units. You're selling 20 of them. So total revenue is quantity times price. So it's the area of this rectangle right here. Now if I sell 1 more unit, I shift out to 21 units, right? The price is now this blue price. So total revenue is this box that's cornered by these blue dots right here. So again, what happened? I sell 1 more unit, right? I go from 20 to 21, and I get P additional dollars for that 1 unit. So that's 1 times price. That's exactly this area B right here. But what do I lose? Right, price drops for all the units I previously sold, which are the 20 units. So for the 20 units I sold, my price now drops by this much. Right, so I'm losing the change in price times the number of units I previously sold at the higher price. So marginal revenue is I gain B, but I lose C. Now, initially at low quantities, the gain B is really big relative to the loss A, because I'm losing that change in price of a relatively small number of units. Versus out here, right, the gain is I'm now getting a lower price per unit, but I'm losing the change in price over a huge number of units. So marginal revenue here, gain minus loss, is lower than it was at lower quantities. Right, so that's where we left off pre-midterm, and you squish that out of your brain so there was room in there for the midterm material. Yeah, so that's what this slide says. The other thing this slide says is for those of you who love calculus, there's at least one of us in the room, you can do a little bit of calculus, and you can just simply derive the change in total revenue due to a change in quantity. That's marginal revenue, right? What's the change in the total amount of money taken in due to the change in quantity? You do the chain rule, and what you get right here is this little formula. Let's zoom in. This is not a high-res thing. I made this on a 2002 IBM ThinkPad when I was still a PC guy, so time has changed. But what this formula says here is marginal revenue is price, right? You sell one more unit, so you get $T, plus the change in price due to the change in quantity. So if you increase output, what happens to the price? Does it go up or down? Better go down. The law of demand. Remember Judge Dredd. I am the law of demand, right? So what you've got here is that output goes up, price goes down, so that first term is negative, and Q is just the total number of units you sold previously. So that first term P right here, graphically, if we look at the second change here, P is D, right? That's the additional dollars you get for that additional unit sold. And C here is the change in price to that increase in output. So it's change in price goes from red to blue times output. That's exactly the area C. So the second term is always the top rectangle. The first term P is the size of that vertical rectangle right here. So I'm explaining the same thing to you three different ways, and hopefully one of those clicks, right? But the big take-home message here, and that's really important, is that for a monopolist that faces the entire demand curve, marginal revenue is no longer equal to price, right? For a competitive firm, marginal revenue is equal to price. Now what's average revenue for the monopolist? How many dollars does he or she get per unit? Just checking your intuition. Not a trick. It's the obvious answer. Say that again. Yep. And what's total revenue divided by quantity? So P times Q over Q. What is that? Price, right? So the monopolist, for each unit he sells, or I'm going to stick to the dude today. All right. So the monopolist, if he sells 20 units, he gets $T per unit sold, right? He doesn't sell each unit like the first box of Microsoft Windows for 200, the second one for 150, the third one for 100. If Microsoft decides to sell 20 boxes of Windows, they'll charge $99 a box, right? So average revenue for the monopolist is equal to the price he charges. Marginal revenue is not equal to the price, right? So I will show you that now, what that means for this linear demand curve specifically. So just to drive this point home, you haven't seen me in a week and already you are annoyed because Max keeps on repeating himself, but for the perfectly competitive firm, price is equal to marginal revenue and average revenue, right? For the monopolist, marginal revenue is not equal to price, right? But price is still equal to average revenue. So for the monopolist, average revenue is price, which is different from marginal revenue, right? For the perfectly competitive firm, the three are the same thing. So let's dive into that a little bit. One other thing I want you to remember quickly, and it's just a placeholder here. I drew this, and this took me forever figuring out how to do epsilon in this old software program. What epsilon stands for? It stands for the price elasticity of demand, right? The price elasticity of demand, to the left here somewhere, demand is relatively elastic. To the right here, demand is relatively inelastic. And right here in the middle somewhere, price is unitarily elastic, right? So what that means is right in the middle here, between the origin and where the demand curve intersects the x-axis right here, halfway between 0 and that point A right here, if you go up, that's the point where the demand curve is unitarily elastic. To the left of that, relatively elastic. To the right of that, relatively inelastic. We remember this from elasticities. I just wanted to bring this back. All right. Now, since this class makes a bunch of simplifying assumptions which really don't affect what we do on a day-to-day basis as economists very much in most settings, let's think about our lovely linear demand curve. All right, so I'm going to make your life pretty simple because you're going to have to draw these pictures over and over again for monopolists because it's a beautiful thing to ask questions about. So if the demand curve is linear, so Max, you're using different words here. You said the demand curve is linear, and up there it says the inverse demand curve is linear. Let me just make a point about why economists are even more annoying than you ever thought. Right? We've been through this before, but let's just reinforce in case you started falling in love with this stuff. Let me bring back the emotions of anger. So a real scientist, right? If a real scientist has an outcome, and he or she is interested in how some right-hand side variable affects that outcome, plots the outcome variable, the y variable, on the y-axis, that's why it's called the y-axis, all right? And plots the thing that's on the right-hand side of the equation on the x-axis. So when economists write down demand, okay, so this here's how scientists would do it. So y equals mx plus b, right? Whatever's on the left-hand side goes on this axis, whatever's on the right-hand side goes on this axis. That's the way we should all be doing it, okay? That's the right way, but we're so fancy. We're going to do this differently because we're economists. We wear suits. So when we write down demand, we always say quantity is a plus b times price, right? That's how you write a demand function. Quantity demanded is a function of price. So what do we draw? We put T on the y-axis and Q on the x-axis. So when we say that the demand function, we think of this, and then we draw the inverse of it, where now my y variable is on the x-axis, and my x variable is on the y-axis. The only thing I can say to that is boo. All right? Unfortunately, that's the convention that everybody sticks with, and that's the way we're going to do this too, because otherwise everybody's going to get freaked out. If you start flipping it, no economist is ever going to understand what you're talking about. Right? So the thing you want to think about here for a second is when we write down the demand curve, we mean Q as a function of T. The inverse demand curve, which is what we plot, right? You just solve for P. So it's going to be P equals Q minus A. So it's going to be, hold on. How about this one? Yeah. Whatever. Doing math in front of people is hard. All right, I should be able to do this, but today's a tough day. So price is a function of Q. So you just rearrange this thing, solve for P, and that's the inverse demand curve. It has the same information in it. It just has T on the left-hand side and Q on the right-hand side. So what we plot here is inverse demand. Inverse demand is P is A minus BQ. What I'm going to argue now, and I'm going to show you mathematically, is that the marginal revenue curve, which we know has got to be different from price, but the marginal revenue curve starts at the same point that the inverse demand curve starts at, but it just has twice the slope. All right? So it's really easy to draw. So it has the same intercept as inverse demand. So on this axis here, it's going to have the same intercept on the y-axis, and it's just going to have twice the slope of inverse demand. What that's going to look like in a second is really simple, right? So you start your demand curve and your marginal revenue curve at the same point. You draw your demand curve first, then you figure out the halfway point between the origin and where your demand curve intersects the x-axis, and that's the point where the marginal revenue curve goes through the x-axis. It's really, really easy to draw. So should we just accept this as a fact? The answer is, of course, no. So let's show this using real math, live math demonstrations. We should do this at Cal Day. Okay. So what I want to show is that the marginal revenue, which is a function of quantity, is A minus 2b times q if my inverse demand curve, P of q equals A minus BQ. All right, that's what I want to show. So all that says is that if my inverse demand is just a regular linear function with a y-intercept of A and a slope of minus B, my marginal revenue curve has the same y-intercept A, but twice the slope. So how do we do that? Okay, we start with this function that Max derived last time, and it was highly confusing, but somewhat entertaining. You guys aren't laughing at my jokes anymore. You guys are tired. Or my jokes are getting worse. I think it's probably the latter. Okay, so what I said last time is marginal revenue is price plus the change in P over the change in quantity times Q. Remember here, this is the vertical rectangle in this picture, and this here is the horizontal rectangle. What on earth are you talking about, Max? I'm talking about P for this thing here is D, right? So it's 1 times the price you get, and the second term, change in P over change in Q times Q, is this distance here is the change in price if you change output by 1 unit, and the length of this box here is how many units you sold. Okay, well that seems like a lot of fun, but that doesn't solve my problem. Okay, well what I'm going to do now is I'm going to, for this thing here, I'm going to plug in my inverse demand function and see if I can get somewhere. So this is going to be A minus BQ. And then this thing here, what is that? It's the change in price due to a change in Q. That's how much price changes if Q goes up. It's the slope of the inverse demand curve, right? What's the slope of the inverse demand curve? It's B, right? Minus B. So I'm going to plug that in here, plus minus B times Q. And there you can see it already. It's A minus BQ minus BQ. It's A minus 2BQ. All right, there's 2 ways that nerds finish their proofs. My least preferred way, because I have flashbacks to German high school, 9 years of Latin, QED. What you set out to prove, right? A much cooler and hipster way. You draw a little box like that, and that states the same thing. That means you're done. All right? So what we showed here is that if inverse demand is in fact A minus BQ, this nice linear inverse demand curve, using this generic statement for marginal revenue and recognizing that price is just the inverse demand curve I've assumed here, and slope here is the one of that inverse demand curve, I can show that marginal revenue has the same intercept A, but twice the slope, minus 2BQ. Now why is this interesting? I'm glad you asked. We're going to answer the single most important question if you're interested in monopolies in economics in intermediate micro. All right, so let's do this. Where does the monopolist produce? Okay, let's answer that question. Start with price and quantity here. I'm going to come up with a demand curve that just spans this space really nicely, so it goes from 10 to 10. Okay, this here, to be precise, is inverse demand, or price as a function of quantity. So where's marginal revenue at? Well, marginal revenue, it starts at the same point as inverse demand up here, but it has twice the slope. So if inverse demand cuts down here at 10, then marginal revenue cuts at 5. So it's really easy. You've got 2 points on the marginal revenue curve. Marginal revenue is a straight line here, so marginal revenue looks like this. That was so easy. Well, Max, that's like a first grader drawing lesson, right? Is there some really intuition hidden in here that's actually interesting? So who here, without looking at this picture, thinks the following statement would be true? The profit-maximizing, super evil monopolist that is a bad guy and all-around bad news ever because he's evil, right, will produce in the portion of the demand curve that is relatively inelastic so he can really, really screw consumers. Who thinks that's a pretty good statement? True? Who else thinks that's true? 2, 3, 4. I think that sounds like a pretty good statement. Who here thinks that's not true? Okay, so we've got 4 in favor, 0 against, and 182 abstentions. I'm glad democracy works. Well, so I said the exact same thing when I was asked this question in this class a few years back, right? So let's look at this for a second, right? So marginal revenue cuts halfway between where the inverse demand curve intersects the x-axis here, right? What else happens at this point, right? We go from marginal revenue being positive to being negative. Is the monopolist ever going to produce, or is any firm ever going to produce where marginal revenue is negative, meaning you produce 1 more unit and total revenue goes down? Nobody's ever going to produce there, right? So the monopolist, we agree, just by saying marginal revenue is negative here, the monopolist never produces here. What's also true at the point where, and I made a hint at that earlier, at the point between halfway between the origin 0 and where the demand curve hits the x-axis? What's true about the elasticity of the demand curve at that point? You're whispering very, very professionally, but I'm deaf, all right? So I'm going to go back to what I said earlier. At that point right here, halfway between 0 and where the demand curve intersects the x-axis, your demand curve is unitarily elastic, right? So at this point right here, epsilon is 1. Now if you go back a couple of lectures, in this range here, the demand curve is relatively elastic, and in this portion here, demand is relatively